All right, hey guys, so we are going to start chapter 5 tonight. Chapter 5 is on rational exponents and radical functions. And the first lesson, 5.1, is on the nth root and rational exponents. So I'm going to present my screen and we'll get started. All right, so starting with the vocabulary, the nth root of A, I'm actually going to describe this as we go through the next set of problems, but we're going to talk about the nth root. That's whatever root you're taking, right? So typically, we look at problems where we're taking like this square root of 4. Okay, we call it the square root. Well, this little number, that is what we call the index of the radical. So it's actually the next term. That's the index, and that's the root that we're taking. Okay, so we might be taking the third root of something like 8. Okay, again, 3 is your index. You might be taking the nth root of some number as well. Okay, we're going to talk about that as we go forward. Right, the core concepts. It says, let n be an integer, n is greater than 1, and let a be a real number, okay? N is an even integer. A is less than 0. There are no real nth roots. If a is equal to 0, there is one real nth root. If a is greater than 0, there's going to be 2 real nth roots, right? If n is an odd integer and a is less than 0, you're going to have one real nth root. If a is equal to 0, you'll have one real nth root. And if a is greater than 0, you'll have one real nth root. So I'm going to be referring to this information as we move forward with the next set of problems that we're going to look at. So let's jump to the next page. Actually, go back to your notes for a second. Underneath the notes here, you might want to just write C examples 1 to 3. Okay, so we're going to do examples 1 to 3, and that's all related to this stuff here, the real nth root. Okay. The next concept are rational exponents. So it says let a raised to the 1 over n be an nth root of a, and let m be a positive integer. All right, so we have some different properties that we can apply. It says a raised to the m divided by n, or m over n, is equal to a raised to 1 over n raised to the n. All right, we can multiply these exponents together. It's called a power of power, which will get you back to m over n. Okay, you can also rewrite it as the bottom number tells you what root to take. That's your index number, and the m is your exponent you apply after you take the root. All right, if we have a raised to negative m over n, so if you have a negative exponent, you guys learned in Algebra 1 to make a negative exponent positive, you drop it down, right? Or if it's negative and it's in the denominator, you bring it up. So that's what they're doing here. And then again, your properties of radicals, power of a power, you can break up the exponent into 1 over n times m. And then the bottom number tells you what root to take. The top number tells you what exponent to apply after you take the root. All right. So let's go through the next set of problems. Oh, go back up. Underneath this, I want to say, see examples 4 to 11. Okay, because examples 4 to 11 will be related to the rational exponents. All right, now let's go down. So examples 1, 2, and 3 says find indicated real nth roots of A. Okay, so you may want to kind of flip-flop and look back at what we talked about here. All right, if n is even, if n is odd. So let's kind of, for the first one at least, go back and forth. So here n is an odd number, right? So n is odd, so I'm going to be thinking about this next, all right? So then what's the a value? A is negative 125. Well, if a is less than 0, there should be one real nth root, and it's the nth root of a, okay? So we're going to say n is odd, a is less than 0, therefore, these three dots mean therefore, there's going to be one real root, okay? So the way we write that is n, the nth root of a, or replacing it with the values, the cube root of negative 125. Right, so what number multiplied times equals 125? Ignore the pen. What number multiplied 3 times? So that can be rewritten as cube root of negative 5 raised to the third, right? Negative 5 times negative 5 times negative 5 is negative 125. And now the cube root and the cube cancel, and you're left with just negative 5. All right, let's move on to number 2. For problem 2, n is even, and a is less than 0. All right, so if I scroll up, that's going to move with us, but that's okay. So if n is even, and a is less than 0, it says no real nth roots. Go down. So we're going to say no real roots. All right, if I write it as the nth power of a, okay, that's going to be the square root of, let me redo that, the square root of negative 400. Well, we know that you can't have a negative under the radical and get a real root. You can have an imaginary one, but there would be no real root. And here's asking for the real roots. Okay, so no real root is the answer there. All right, and problem number 3. Excuse me for a second. Sorry, I just had to yell at my children. Okay, so here n is even, a is greater than 0. So let's scroll up and see what we're supposed to have. Ooh, other way. If n is even and a is greater than 0, there should be 2 real nth roots. So it's going to be plus minus the nth root of a. Okay, so we'll go back down. All right, so not too far. So it's going to be plus minus the nth root of a. Okay, so it's going to be plus minus the 6th root of 64. All right, so what number multiplied 6 times? Oh, I didn't mean to do that. Let's do that again. N is even. A is greater than 0. So it's plus minus the nth root of a plus minus the 6th root of 64. So what number multiplied 6 times equals 64? 2. 2 to the 6. Don't forget your plus minus like I. All right, so the 6th root cancels with the exponent 6, and you're left with just plus minus 2. And that's your answer. All right, let's keep on moving along. All right, evaluate the expression without using a calculator. So obviously we can plug these in the calculator, and you're welcome to do that to verify and to check, but I do want you to understand how to rewrite these and simplify them without the use of a calculator. Okay, so this is referring to what we talked about up here, the rational exponents, all right, and some of the properties there. So the bottom number of your exponent What's going on with my pen tonight? The bottom number of the exponent tells you what root to take, and the top number tells you what exponent to apply. So we rewrite this problem as the square root of 64 raised to the first. Okay, well, the square root of 64 is 8, and then 8 raised to the first is simply 8. All right, the next problem. Excuse me. Again, bottom number tells you what root to take, so it's going to be cube root of negative 27 raised to the first. Okay. Now, when you have a negative number under and an odd index, that's okay. The problem is if you have a negative number and an even index, there's no real roots if that's what we're looking for. All right, but we can rewrite this as the cube root of negative 3 cubed, right, and then raised to the first. Well, the cube root and the cube cancel, so it's just negative 3 raised to the first, which is simply negative 3. All right, I'm going to delete those, and we'll keep on moving along. The bottom number tells you what root to take, the fifth root of 32 raised to the 7th. All right, well, what number multiplied 5 times is equal to 32? If you have 2 and you multiply it out 5 times, 2 times 2 times 2 times 2, right? All raised to 7. So the fifth root cancels with the exponent 5, so you're left with 2 to the 7th. And then 2 to the 7th, so 2 times 2 times 2 times 2 times 2 times 2 times 2 is going to give you 128. All right, for the next one, the first thing I'm going to do is make the exponent positive. All right, so to make the exponent positive, if you remember from Algebra 1, we rewrite this as 1 over 49 raised to the 3/2. Now I'm going to apply what we've learned tonight, or today, whatever time you're watching this video, that the bottom number tells you what root to take, the square root of 49, and then you raise it to the third power. Okay, so the square root of 49 is a 7, and then you have 7 cubed, which is 343. 1 over 343. All right, continuing on, so the bottom number tells you what root to take, the top number what exponent to apply, so the fifth root of negative 32 raised to the third. So what number multiplied 5 times gives you negative 32? Well, it would be a negative 2. Right, if you have a negative 2 times a negative 2 times a negative 2 times a negative 2 times a negative 2, that's negative 32. So the fifth root cancels with that exponent 5. So you have negative 2 cubed. So negative times a negative times a negative is going to be a negative. 2 times 2 is 4 times 2 is 8. So negative 8. All right, let's go to the next one. Make the exponent positive first. So it's going to be 1 over 1,000 raised to the 2/3. All right, then what we've been doing, I'm going to work horizontally because I'm going to run out of room if I go this way. Bottom number tells you what exponent to apply, so the cube root of 1,000, and then squared. Well, the cube root of 1,000 is 10, right? And I could rewrite it as 10 raised to the 3rd. So the cube root and that exponent cancel. So you're left with 1 over 10 squared. 10 squared is 100. So 1 over 100. Okay. So that's number 9. Number 10, the fourth root of 81 cubed. So what number multiplied 4 times is equal to 81? And if you're not sure, guys, you can always come over and do like a factor tree. So if you're not sure how I'm getting these values so quickly, you can come over and do a factor tree and break it down into the primes. That's always a good idea, right? So 3 4s. So I can rewrite square root of 81 as 81. Oh, no, that's not how I want to write it. I can rewrite the square root of 81 as, try this again, the fourth root of 3 raised to the fourth cubed. So the fourth root and the exponent of 4 cancel. So you're left with 3 to the third. And 3 to the third is 27. All right. Problem number 11. Bottom number tells you what exponent to apply. So the fourth root of 625 raised to the first. Again, if you're not sure what numbers multiply 625, break it down to its primes, okay? You're going to get that it's 5 fours. 5 raised to the fourth. So the fourth root and the exponent of 4 cancel, and you're left with 5 to the first, which is simply a 5. All right. Let's keep on moving along. All right, match the equivalent expression, explain your reasoning. Sometimes I think it's easier not to try to like figure out, but actually go through and just rewrite these in another form and then figure out which one it matches. All right, so it's kind of up to you if you want to look at the answer options and look at the problems and try to decide, you know, which one it matches with, or rewrite each one in a new form. So in other words, instead of in radical form, rewrite it with a fractional exponent, a rational exponent. Since this is a square root, right, we don't write the 2, but that's the index is a 2 because we call it a square root. That means that can be rewritten as a to the 3 over 2, right? The bottom number tells you what root to take. The top number tells you what exponent to apply. Okay, so after I do that, I know that it matches with B. All right. The next one. Well, the top, or excuse me, the index number is the bottom. And the top number is what exponent to apply. So when there is no exponent out here, right, it's automatically a 1. So it's negative a to the 1/3, which matches with D. All right, for this one, the index number is the bottom. And then that exponent is the top. So it's a to the 2 over 3. Oops, did I point to the wrong one here? I did. I pointed to B. It's actually A. I wasn't paying close enough attention. Let's erase that. The answer is correct. I just pointed to the wrong answer option. So 3 over 2 is C, not B. So this one is C. This one is B. And then finally, because this is down in the denominator, that tells me that I probably had a negative exponent. So I'm first going to write it as one over A. Let me move it up a little bit because I'm too low. 1 over A to the 1/3. All right, and since that's still not an answer option, but I see that negative exponent, well, if I move it up top, the exponent becomes negative. So this matches with A. Okay, let's keep on moving along. All right, excuse me. Find the real solutions of the equation around your answer to 2 decimal places when appropriate. So you want to isolate the variable, all right, and then we're probably going to have to take like the cube root, the fourth root, the fifth root of both sides of the equation, depending on what the exponent is that's given. All right, so isolating the variable, divide both sides by 6, and I'm left with x to the third equals -1. To get x alone, I take the cube root of both sides. And the cube root of -1 is simply a -1, right? Because -1 times -1 times -1 is -1. All right, so x is equal to -1. For number 17, first divide both sides by 2. You're left with x plus 5 raised to the 4th equals 64. All right? Then what we're going to do is take the square root, or not the square root, excuse me, the fourth root of both sides. So you're going to have x plus 5 is equal to plus minus the square root of, I keep saying square root, but it's not. It's the fourth root of 64. Now, how did I know it was plus minus? It's because of what we started class with. Because n is even, right? And 4, the n is a 4. And because my a is greater than 0, your a value is 64, that indicates that there should be two real, oh, I'm off the screen, real solutions. So if there's two real solutions, I need that plus minus, okay? All right, so from there, oops, I got the pen. What number multiplied 4 times equals 64? Okay, well, if it's not a perfect fourth root, if there is no number that multiplies 4 times, then we're going to have to use our calculator. But before I do that, actually, I forgot I still have that plus 5 on the other side of the equation. So let's not simplify yet. Let's move the 5 over by subtraction. So I have x equals plus minus the fourth root of 64, and then I'm subtracting the 5 over, so minus 5. Okay, so I'm going to use my calculator now. Where should I go? I'm going to go over here, erase this. Second plus 712, just to reset it real fast. Okay, so I want to know what is the fourth root of 64. Okay, pretty sure it's going to be a decimal. Now to, let me show you, by the way, how to do this. To write your own index value, because we don't want to use the square root button, right? Because that's only for an index of 2. So I'm going to hit math and go down to option 5. That's going to allow you to put whatever index in that you want. So I want to know what is the fourth root of 64. And then I'm going to subtract 5 away. So one of my answers is, what does it say to round to? Round to 2 decimal places. One of my answers is that x is equal to negative 2.17. And then I have another answer, because then I'm going to also have negative, oh, try again, negative fourth root. Sorry, guys, let's do this. Fourth root is 64, but we want it to be negative. Okay, so negative fourth root is 64, and then subtract the 5 away. So your second answer is negative 7.83, rounded to 2 decimal places. All right. Okay. Problem number 18. So let's first add the 32 to both sides to isolate the variable. So I have x to the 5th is equal to negative 32. I'm going to take the 5th root of both sides. Whenever your index is an odd number, you're never going to have plus minus. It's only when your index is an even number, and I can show you back up at the chart to explain that more. All right, what number multiplied 5 times is negative 32? Well, I can rewrite that as negative 2 raised to the 5th. So the 5th root cancels with the 5th, so x is equal to negative 2. Okay. And the last one from this section. Subtract 100. Oh my goodness. We're doing pretty well. Subtract 100 from both sides. So I have negative 1/10 x to the 3rd equals negative 100. Then I'm going to multiply both sides by the reciprocal, so it's negative 10. Multiply this side by negative 10. So I have x to the 3rd is equal to 1,000. Okay, now this is going to be a little bit, well, it doesn't have to be. I can just take the cube root of both sides, right, to get rid of that exponent. That's one option. I do want to show you a different way of writing this. Actually, no, I'm going to stick with how we've been doing it. I changed my mind. All right, so at this point, we're going to take the cube root of both sides. So the cube root and the cube root. So you have x, oh, went too low. X is equal to the cube root of 100, or 1, oh, I missed a 0. I think I said 1,000, but only wrote 100. 1,000. So x is equal to 10. All right. And the last problem says the volume of a cube is 1728 cubic inches. What are the dimensions of a cube? Well, a cube has all the same lengths for all sides, right? All the sides are congruent if it's a cube. And the volume formula to find a cube is length times width times height. But remember, for a cube, like I was just saying, the length is equal to the width, which is equal to the height, right? If you were to draw a cube, this is not going to be the best cube, but when it's a cube, the length, the width, and the height are all the same, right? So instead of length times width times height, you can write it as side cubed. Okay, if that doesn't make sense to you, you can say let S equal L, which is equal to W, which is equal to H, and you're replacing L with an S, W with an S, and H with an S. So S times S is where the S cube comes from. Now the volume is given, that's 1728. So 1728 is equal to S cubed. So to solve for the length of each side, which is the dimension we're looking for, you just have to take the cube root of both sides. All right, now this is not a number I'd expect you to know the cube root of. So you could either use your factor tree or plug it into the graphing calculator. Math, go down to option 5. We're looking for the cube root of 1728. And you get 12. So S is equal to 12. Okay, so what are the dimensions of the cube? The length is equal to 12, the width is equal to 12, the height is equal to 12, because each side is equal to 12. And that's it. All right, guys, so let me stop presenting. That is it for lesson 5.1. I will see you back here for the next lesson. Bye.